All right, so the focus of this lesson is on finding lines of best fit. Now, our objective here is to create a line that will approximate the data in this scatter plot. So let's take a look at what we have here. If you look here on the x-axis, we see that we have temperature, and on the y-axis we have sales. And we can see that as the temperature goes up, it appears the sales is also going up. So let's look at what they're selling. Okay, so we can see here that this is for ice cream sales in comparison to temperature. And we're seeing a similar thing in the table here, right? As the temperature increases, so does the sales. Now, on number 1, they want us to draw an approximate line of best fit for the scatter plot. So ultimately, what they want us to do is create a line that goes approximately through the data. Now, we know it's not going to be perfect simply because these scattered points don't fall perfectly on a line. So what we're going to do is we're going to carefully place our ruler. We're going to try to closely match as many of these coordinates as we can, knowing that it won't go through perfectly, but we want it to go through as many as we can possibly make it. All right, so you'll notice here that it goes through about 1, 2, 3, 4, 5, 6-ish points. There's about 3 left over on top and maybe 2 or 3 left over on the bottom. We're happy with that, really because we know it's not going to fit perfectly, right? And this does seem to have the same sort of trend as the data we see here. Now, number 2, they'd like to identify the independent variable. Now, this is a variable that is not directly affected by the other. So we have 2 variables. We have temperature and sales. Now, we know that sales is affected by temperature, right? So as the temperature increases, the sales change. But we can't say the same thing in the other direction, right? So if ice cream sales start going up crazy, does that mean the temperature for sure has changed? No. So we're going to say that temperature is actually independent of sales. So we're going to put that as our independent variable. Now, dependent, that's the variable that is directly affected by the independent variable. So if I change the temperature, does that generally have a direct causal relationship on sales? It does. When we see that, because in the spring and the summer, we see people buying ice cream more often. So we're going to put here ice cream sales as our dependent variable. Now, number 4, they'd like us to identify the domain. Now, domain, in case you don't remember, is just the set of all possible x values. Now, in this case, we know that our temperatures are x values and our ice cream sale is our y. So if we look closely here, we can see that they range between about 11.9 degrees all the way to 25.1 degrees. So we're going to say that our domain is about 11.9 degrees Celsius to about 25.1 degrees Celsius. Now, our range is the set of all possible y values. All right, and now we look over here, we can see that it seems to range between about 185 and 614. So we're going to say our range is between 185 and $614. All right. Now, what they want us to do on number 6 is to identify the slope for this line of best fit. Now, in order to identify a slope, we need 2 points on the line. So I'm going to look closely, and it does appear that this point right here goes through quite nicely, as well as possibly this point right here. So I'm going to go ahead and I'm going to use those 2 points just because my line fits nicely through each of them. This point here is actually my lowest point, and then this point here is actually my highest point. And it will not always be the case that you use the lowest and the highest, but here it actually worked out quite nicely. So if I remember correctly, the slope, also known as m, is my rise over run, also known as y2 minus y1 over x2 minus x1. And this really just means we have 2 data points, x1, x2. And remember, that just means we have 2 separate x values. and then two separate y values, y sub 1 and y sub 2. And we're just going to find that difference in the rise, right, how much we went up, and that difference in the run, how much we went over. So we're going to take that 614, and we're going to subtract 185, and then we're going to find that difference in our run, which was that 25.1 degrees Celsius and 11.9. And we're going to figure out our slope. So let's start with the numerator. 614 minus 185, and that gives us, looks like $429. And then on the bottom, we have 25.1 degrees Celsius minus 11.9, which gives us 13.2 degrees Celsius. Now, ultimately, when we write our slope, we would like this to be simplified. So we're going to take that 429 and divide by 13.2. And we can see that it appears that our ice cream sales are going up about $32.50 for every 1 degree Celsius increase in temperature. So we can then say that. So let's write that down here. So we're going to say, as the temperature increases 1 degree Celsius, the ice cream sales increase by $32.50. Or we might also say something to the effect of, for every 1 degree Celsius increase in temperature, we have an increase in sales by about $32.50. All right, so on 7, they would like us to identify the y-intercept. Now, of course, we could look at the graph and we could say, oh, it's about 100 and something, but I don't think that's precise enough for what we would like here. So instead, we're going to look at what we know. We know that when we write the equation of the line, that it should be in the form y equals mx plus b. Now, right now, we do know m, right? We know that m is that 3250. So I'm going to go ahead and label that. Now, we want to find b. We don't know b. We don't know the y-intercept. But we do know some x's and y's. So what I'm going to do is I'm going to go ahead and I'm just going to take this one right here. It doesn't matter if we take the first one or the second one, but I'm going to take that second one. So I have 614 for y, and I have here 25.1 for x. And what I'm going to do is I'm just going to substitute those values into this equation for a line. And then I'm going to solve it for b, or y-intercept. So I'm going to go ahead and take that 3250 and multiply it by 25.1. So I notice here that if I want to solve for b, I need to subtract that 815.75. And then I can see, if I use my calculator, that my y-intercept is about negative $201. Now, some of you might be confused by this, right? So you're saying, how could it be negative 200 when it appears the y-intercept is 100 and something? Well, here's the issue, right? So remember, y-intercept in mathematics is the point at which the x value is 0. See this here? This is 10. Because this is at 10 and not at 0, you would actually have to extend this graph, right, until we got backwards to where 0 would be. So it totally makes sense that this would be negative. So it appears then that the equation of this line is y equals 3250x minus 201.75. Now, we should definitely make sure this makes sense by plugging in, let's say, our first point. So if we take our x sub 1, which is 11.9, so we have 3250 times 11.9, and then we subtract that $201.75, we should get 185. So we're comfortable with this. Now, the question here, it says interpret the y-intercept in the given context. So in theory, this is kind of funny. This would be where x was 0. Now remember, x is the temperature. So we're going to put here, at a temperature of 0 degrees Celsius, ice cream sales would be negative $201.75. In other words, you would actually have to pay people to take it. And while that's not super realistic, in some ways it does make sense, right? People don't want ice cream when it's that cold. All right, let's look at number 8. Given a temperature of 20 degrees Celsius, what would you predict the ice cream sales to be? And then is this an example of interpolation or extrapolation? So first off, let's look here. So they're giving us a temperature and it's 20 degrees Celsius. Now we do want to note that we do actually have an equation now that allows us to determine answers to all sorts of questions, right? So we know here, of course, that y is sales and that x is our temperature. Now they've told us here that the temperature is 20 degrees Celsius, meaning we can simply take this equation and let's plug in that 20 degrees Celsius and actually calculate for the sales, okay? So we're going to say y is equal to 3250 times our 20 degrees Celsius minus 201.75. And then we're just going to grab a calculator and have it do the work for us. All right, and it looks like sales will be at about 448.25. Now let's look at the graph and just kind of see if that makes sense. So if we went to 20 degrees Celsius on the graph, would 448 approximately make sense? It would. So we feel good about that. Now the question here is this an example of interpolation or extrapolation? So in mathematics, interpolation is the idea of making a prediction that is within your scatterplot data. So does that 20 degrees Celsius fall inside this data right here or outside? Now we look here, we can see that 20 degrees is most definitely inside our domain and our range. Therefore, this is going to be an example of interpolation. If we were to have to make a prediction that was, say, 10 degrees or 30 degrees, then that would be an example of extrapolation. So we're going to put here, this is an example of interpolation because 20 degrees Celsius falls inside the domain of our data set. And that's it. Now it's your turn to give it a try. So take a look at the music sales graph and identify the line of best fit, the independent and dependent variables, domain, range, slope, y-intercept, and make a prediction. Submit your work on Canvas.